Okay, Math 20, here we go. Pretend this is you sitting in your favorite spot. And I'll give you a little tour around so you remember, oh yeah, how much I loved this. This was so great. There we go. Oh, the door to get out. No one wants to use that. Look at that. All my books, still a mess, all over my desk, as usual. And there we go, all of the great memories. Okay, Math 20, this is 8.3. I hope you have a little bag of snacks for yourself and make you happy while you work. Here we go. So 8.3 is solving without technology. And they review the linear equalities in one variable. But here's what we need to know. Lots of this we used in grade 10, but that was a while ago. So linear inequality boundary line satisfies the equation. And your equation for a line, you're going to use the slope formula. M equals rise over run, or M equals y2 minus y1 over x2 minus x1. Memorize this, buddy. Slope y-intercept equation, so y equals mx plus b. Slope is the m part, and the y-intercept is the b. Slope point form we learned in grade 10, and it can be handy. Y minus y1 equals mx minus x1. And really that comes from cross multiplying here and here. Okay, example number 1. Consider the inequality, and now we'll solve algebraically. So I am going to rewrite, I guess, 2 bracket 3 plus x, end of bracket, greater than 12. And now I'm going to move the 4, take away 4, take away 4, negative 2, bracket 3 plus x, end of bracket is greater than 8. Divide by negative 2. When I divide by negative, my sign switches. So 3 plus x is going to be less than negative 4. Take away 3, take away 3. X is going to be less than negative 7. And they say check using a test case, and this is fine, but really not essential. I'll talk about that more later. So I'll just do an example. A test case, you're going to pick something less than negative 7. So why don't we test for negative 10? And what if x equals negative 10? So back to our original equation, 4 minus 2 bracket 3 plus x is greater than 12, and now we substitute that in. So minus 2, 3 plus x is greater than 12. 4 minus, whoops, that was supposed to be the 10 going in there. Here we go. Minus 2 bracket 13, end of bracket is greater than 12. 4 take away 26 is greater than 12, and negative, that'll be negative 22 is greater than 12. That's not true. Okay, what happened? X is less than negative 7. That's less than negative 7. Back into our original. And we wrote the original correctly. Oh, I put plus 10. Should have negative 10. I hope when you did yours, it worked out. Okay, so negative 10. And now that'll be negative 7, which will give us plus 14. And 18 is greater than 12. Great. So really what this does is it kind of says your answer is right. It's like a sort of a verify. The problem with it is it doesn't actually verify this number. This 10 could be right, but what about negative 8 or a negative 7.5? Really, you should verify that boundary and then verify that a number less than that will also work. So that's why I kind of say it's fine. graph the solution on a number line. So our solution, x is less than -7, so -7 less than and not including, and down we go. Scrappy, good enough. Okay, next page. Now we're going to get lines. So the following are examples of linear inequalities in two variables. So equations of lines is what they're saying. Whoa, did you see that? Okay, here we go. The solution boundary to a linear inequality in two variables can be represented on a coordinate plane, in other words, a graph, using a boundary line and shading one side of the line. So the boundary line will be solid or broken according to the following rule. It's going to be a solid boundary line if it's with an equals. So your answer could be on the line is what it's saying. And it's going to be a broken or dotted boundary line if it is just greater or less, not actually equal. Okay, they do some nice rules for graphing. I think it's easier if we do this. So pause, write those down. And now let's use those to graph here. So number 1 says solve for y equals. So let's do that. So 3x minus 2y less than or equal to -6 and minus 3x minus 3x. Negative 2y is less than or equal to -3x minus 6, divide by -2, divide by -2, divide by -2. Y is greater than or equal to 3/2 x plus 3. So we've solved for the y equals, and by y equals I mean y and then whatever comes with it. So now we'll have a y greater than or equal to 3/2x plus 3. And now I'm going to graph this. I know this is my slope, this is my y-intercept. So up I go to my y-intercept of 3, and then I'm going to use my slope, which is rise over run, so up 3 and right 2. And I could go down 3 and left 2. And then use a straight edge because it's just much neater and easier. There's my line. And so graph the y equals. Great, I did. Whoops, I didn't read carefully. If less than or equal to, or greater than or equal to, I'm going to do a solid line, and it is. So that's good because I already did a solid line instead of a dotted. If y is greater than mx plus b, shade above the line. It is greater, so I'm going to shade above the line. And I'm not going to shade perfect or it'll take too long. So what that means is every number in here, including numbers on this line, are solutions to this equation. So they will satisfy the equation. And if we chose something, like let's pick something easy in here, what about -4 and 0? That would be easy. So -4 and 0, this is my x, this is my y. If I put them into the original equation, 3 times -4 minus 2 times 0 is supposed to be less than or equal to -6. So -12, take away nothing, is less than or equal to -6. -12 is less than or equal to -6. So not a real verify, it just shows that, oh yeah, that is one of the answers. Lots of answers to these kind of questions, which is why you graph the solution instead of answering all of the numbers. Okay, example 3. Okay, pause the video. You can do this one without me. Okay, let's look. So they have done all the easy work, all the work part for us really, and now we can just graph. So y-intercept and, slope, y-intercept, and this is going to mean that my line is going to be dotted. So y-intercept of 3, 1, 2, 3. 3/4, so rise of 3, 1, 2, 3, run of 4, over 2, 4. Or I could have gone down 1, 2, 3, and left 4. And then I'm going to use my straight edge and draw a dotted line. So that will mean that my answers do not include anything that is actually on the line. And I need to shade below. Okay, ta-da, that's it. Number 4. The diagram shows the solution region to an inequality. The boundary line has intercepts at -2 and 0 and 0 and 4. Find the equation of the boundary line. So from grade 10, we need the slope and we need a point. So slope, m equals y2 minus y1 over x2 minus x1. There we go. M equals y2 minus y1 over x2 minus x1. In go my points. So if this is my point 1, then this is x1 and y1. This is x2 and y2. So 4 minus 0 over 0 minus 2 is 4 over plus 2, which is 2. So slope is 2. Point, I've got 2 of them. I'm going to choose one. So I think I will choose that one just for fun. So -2 and 0. And now I'm going to use this equation again. So m equals y2 minus y1 over x2 minus x1. And input my information. Slope is 2. And I've got y. You leave the y for the y2 part because you need an x and a y in the equation. So you'll have a point, but you'll also still keep an x and a y. So y minus 0 over x minus a minus 2, so that'll be positive 2. Cross multiply 2x plus 4 equals y. And wow, I'm all done. Nothing here. Okay, so that's the equation of my line. I need now to make the inequality. So I'm just going to rearrange this for a second. Y, and then I will wait 2x plus 4. I know because it's a solid line, it will have an equal part, and I'm shading below, so it will be less. And, oh, I just did that part B in here. So, fantastic. This is a nice one. We are going to do questions 1 to 10. Don't do 1B, 2B, or 5. And on number 2, make it easy for yourself by multiplying by the common denominator on each term very first, and that will get rid of the fractions for you. Okay, have a good time.